Hello, I came up with a very cool and nice paper by Dr. Martinez Lozano and others that describe really nicely the staging of orthodontic appliances. So this paper here is called Staging, as you can see, of orthodontic tooth movement in clear aligner treatment. And it has some interesting points that I would like to discuss with you. Inside this paper, and that comes from this paper, by the way, they describe the aligners as a closed system, which means that all the teeth are enclosed within the aligners. They cannot really be moved out. It's unlike a wire that can be expressed distally, let's say when you are aligning the dentition, and has this capacity of expressing some energy by just expanding to the distal. Obviously, we all know that aligners only are push surfaces and do not allow for pull. You have to understand the biomechanical concept that only delivers push. That's why we use attachments and all sorts of other auxiliaries to get into a favorable tooth movement. And obviously the concept of differential anchorage, which has been described many times and is used in orthodontics for basically fixed orthodontics or aligner orthodontics or anything. So the differential anchorage means when the segments are moving differently, but it applies in a very specific way for aligners. Then you have to ask this very important concept of sums of moments and sums of forces have to be equal to 0. And remember what you have here. You have a closed system. And aligners work into this closed environment, and the dentition is locked into the aligners, and on top of it you are working with plastic deformation. So it's a very completely different way of moving teeth than you have with fixed orthodontics. And basically what you do from, let's say, stage 1 to stage 2 is the aligner is slightly deformed, has a different shape, and because you're pushing, there is some voids in there that allows the dentition to move into its new position. So that's a very important concept. If you cannot have static equilibrium when you stage the case, so remember, when you will be staging the case, just don't look at the cute video games that you're seeing. Just find where the teeth are moving, which force are applied and which moments are applied, so you can try to find forces that cancel each other or moments that cancel each other but allow tooth movement. But you can also increase or decrease the anchorage at will, depending again on the force system that you will be using. What happens also for aligners is the force system, as just described, the sum of force is applied to the tooth and also to the aligner. So again, this deformation will move the tooth, so this tooth will respond by moving in all sorts of directions, probably a push. And the aligner will be deformed with an elastic deformation, but all these forces are 0. And when you're going to start rotating the teeth or applying rotational moments to counteract a natural tendency to tip the teeth if you want translation, again, these teeth here will feel counter moments and forces. But all these, again, need to be equal to 0 and have to be mathematically calculated and not just moving teeth in a certain direction and not being able to counteract the forces that are applied, which means that because you're in a closed system, you may end up with unwanted tooth movement and lack of tracking of the aligner. So in conclusion, from this pretty interesting article, and I wanted just to make a very short presentation, you have a closed system that is actively being deformed to very small increments, but still. So you have deformation of the aligners. And then what happens is same principle as night eye or even stainless steel. If you are within the plastic deformation or the elastic limit of the aligner material, you will get a return to its shape that has been determined by your staging, and hopefully the tooth or teeth, depending on what you want to do, will move where you want them to be. But remember that you may have teeth that want to rotate this way, teeth that want to rotate this way, or you may want to have a moment to force ratio to upright dentation. So always try to find equal or opposite moments that cancel each other, that do not place any strain on the system. So this way you will get a much more predictable treatment, because remember, if you only have moments that are going into one direction with your staging, well, at one point this has to be counteracted by a large moment on the other side, and you may end up with unwanted moments. So always the best thing to do is to try to find the forces that are in different directions, not necessarily exactly equal, and the moments that are in different direction within the arch, so you get as close as possible to zero. And by having a zero form, you get biomechanical equilibrium, which means you will get a great treatment. So always think about that. And with this, I thank you for your attention. Thank you.